Shall I? So we talked about two other types of cash flows. So you know how to value an annuity, right? Same thing using the present value function, except that you would use the PMT to signify that's an annuity. The only complication for which you need a formula is a growing annuity, right? For which there is no special formula in Excel. So that is why you want to program it in Excel and use it. So this formula which I have here, this is nothing but that formula just programmed in the Excel, so that you can just plug it in and get it. Okay. So question for you, can G be negative? The answer is yes. It's only R that cannot be negative. R is the interest rate. So that is the one that cannot be negative. But G can be positive or negative. The only thing that you want is R should be bigger than G, because you are subtracting R minus G. Okay, so that's the only thing that you need to keep in mind. Otherwise, so the second key idea, yes.
I just had a question. Suppose the growth rate is higher than R. So we won't be using the Excel, but we can still do the calculations, right? There can be cases where the growth rate is higher than the interest rate.
Okay, so his question is, so this is a formula for the present value of an annuity, right? Suppose R is 10%. For the formula to work, G has to be less than R. But what if G is 15%, then R is 10%? Then it will be a negative number, right? Then it doesn't make sense. Present value of something which is all positive, it cannot be making sense. The answer cannot be negative. So therefore, this formula will only work if R is greater than G. Now, this is a type of an example that you had in one of your problem sets where the sales for the project was fixed. Do you remember the problem? So the sales was $100 every year. This is in problem set 2.
Oh yeah.
But then the costs were $50, so this is sales. But costs were something that was growing at 19% every year. Right? So the question was trying to figure out what is the profit. Now that is an example of something like this, and the discount rate in this problem, so the G was 19%, but R was equal to 10%. So that's an example of a growing annuity or perpetuity. So if you try to apply the formula 10 minus 19, it will give a negative answer, right? Which doesn't make sense. Because the cost is also numerator is negative, the denominator is also negative. So the negative and negative will cancel, and so you get a positive answer, right? That doesn't make sense, because if you're adding all the costs, it should give you a negative number. Do you see what I'm trying to say? So therefore the formula cannot be applied. So then his question is, how do you handle those situations? Now, in this particular case, you can figure out and argue that the revenue minus cost should be positive for you to do the project. At some point, this $50 would grow up in such a way that by year 4, the revenue is still 100, the cost is $102, because it's growing at 19%, right? So by year 4, the cost will become 102. Now, at this point, when you do the project, the answer is no. So therefore, you have only 3 years to figure out, which you can manually calculate. Intuitively, what's going on is you can't keep on growing costs, and you will walk away from the project. You will not do a negative project. So in other words, if that condition is not satisfied, you have to use common sense. If R is greater than G, the formula would work. But if that condition is not satisfied, then you have to figure out what is the thing that is making the formula break down and use.
So in any case where G is greater than R, you're not gonna wanna do it in the long term, but in the short term, there could be benefits where as long as you stop in time where your costs are less than your
So
sales.
let me phrase your question differently. So you said when G is greater than R, you don't want to do the project. No, actually you want to, because if growth rate is so good. Provided it is revenues, then you want to do the project. If it is cost, then you don't want to do the project. It depends on the circumstance. So now the next question that you asked is, how do you handle such situations when the formula doesn't work? You have to separate out the time when the formula doesn't work, when G is greater than R. But then most of the situations, this high growth cannot last forever. Take for example Google, right? Google had very, very high growth starting from 98. But at some point, the growth has to slow down. However big, think about it this way. Suppose if it's a firm that has $1 today, and it becomes $2, the growth is 100%. Now, from $2 it becomes $3, the growth is not 100%, it is now 50%. And 3 to 4 is only 33%. So growth slows down. So at some point, there will come a point when the formula would again work, because G will become less than. Because you cannot keep growing at that rate forever. So, if you keep growing at that rate, you will become the economy itself. So if you become the economy itself, then you will have the economy's growth rate. So therefore again the formula will come. You see what I'm saying? So that's the logic. Okay. The second key idea in that week is about that notion that it's compounding. Okay. So what is compounding is, you have an interest rate, so let's say it's 1 year, okay? But then we are going to have compounding every month. So 1/12, 2/12, all the way. First month, second month, and so on. Suppose the interest rate is 12% per annum. The per period, the interest rate is 12% divided by 12 months in a year, so it's equal to 1%. So this is given a special name, this is called APR. The key point to remember about the concept of compounding is, while it is 12% per annum, if you are compounding it monthly, what will happen is, if you start with $1, in 1 month it will become $1.01. But then, in the second month you will earn interest both on the original dollar as well as the cent. That's the idea of compounding. And while it might seem like a small thing, over a long period this compounding adds up, and so it creates big differences. So that's the key idea that you want to remember as far as compounding is concerned. So in any problem of this kind, you have to ask yourself the question, what is the APR, which is what we call as R here, right? Because everything is standardized way of representing stuff is people will always say the annual percentage rate. So that's the APR. Then the next question you have to ask is, how frequently do I compound? So if it is monthly, then MS12. If it is semi-annual, MS2, because there are 2 compounding periods and it is 6 months. And if it's quarterly, then it is 4, because every 3 months. So that is what helps you figure out 10. Okay. Now sometimes you might see the formula not in this form. Sometimes I might put the rate as 1 plus some periodic rate to the power n. In other words, suppose it's a monthly compounding, then if I put a monthly rate, that is what is R divided by M is. Do you see what I'm saying? Let me. So I can write it like this: 1 plus the APR is 12%, so 12 compounding periods, so divided by 12 to the power 12 minus 1. So this is one way in which you would see the formula for the effective annual rate. Okay. Sometimes sometimes I might write it like this. 1 plus the monthly rate to the power 12 minus 2. These two are the same formula, you should not get thrown off, right? In one case, we said that it is annual rate divided by 12, which is 1%, and then we wrote it according to the formula, so it looks exactly like this formula. But some other times I might find out the monthly rate during, doing some calculations, so I'll just put 1 plus the monthly rate to the power 12, because all we care about here is the periodic rate. R divided by M is what is known as the periodic rate. So you might see the formula applied like this, which is the same formula, but this should not throw you off. You see what I'm saying? Instead of saying 12 divided by 12, I might have just put 1 plus the monthly rate to the power 2. If it is 1 plus the quarterly rate, then it should be the power 4. If it is 1 plus the semi-annual rate, it should be the power 2. So you might see the formula, written that way. Okay? So it's the same thing. So don't. So again, if you have to figure out the EAR, as long as you know the compounding frequency, okay, then you can use that and figure out the EAR using that formula. I just programmed it, so you can do it directly. Now, should compounding be always done in frequencies less than a year? Can you do it in greater than a year? You can? Okay, so let me ask you a following question. So tell me, what should be the EAR in this situation? Suppose I have a series of cash flows, okay? 0, 1, 2, 3, 4. Okay? So let's say I get nothing in the first year, but then I get, let's say, plus 100. Okay? I get nothing in the third year, I get plus 110 here, and so on. In other words, the cash flows come every 2 years. The discount rate, or let's say it's 15%, but it is for 1 year. How do I figure out the present value for this?
1 plus the R over 1/2 to the 1/2 power or whatever.
1 plus
Minus
R
1.
raised to power R by M minus 1.
Yeah, it's the power 1/2 for sure.
To the power half, 1/2.
So is a question clear? So I'm having cash flows that come only every 2 years, but the interest rate is per year, so I have to figure out the present value. The brute force way is just put it in Excel, put zeros in between and then you can calculate. But what if this was an infinite perpetuity? You can't do that, right? So you have to figure out the rate which works, which is the EAR for every 2 periods, right? Because I can rewrite this thing as every 2 period is 1 time period. Then if I know the interest rate during this period, okay, if I can figure out what this interest rate is, let me call it as capital R, then it is like a regular problem, right? Because this is the interest rate every 2 period, but then I'm also getting the cash flow, so I'll get 100, 110, etc. it goes. So if I know this, then it's like a standard formula. Do you see that? In other words, it's pattern recognition. As long as you recognize this pattern as a standard pattern, you can apply your formula. Now the question is, how do I figure out this capital R? The logic that you use is exactly the same that you use for figuring out for frequencies less than one year, right? So the question you have to ask is, supposing I start with $1, 15% is the interest every period. How much will I get at the end of 2 years?
$1.23.
Tell me the formula.
Would be 1 times 0.15 squared or something like that.
1 times
Or 1 times 1.15 squared.
to the power
Two.
Two.
Do you agree with this?